Okay, this is going to be generally going over the general function rules. When you graph a function in your calculator, whether it's Desmos or your graphing calculator, you have to define what that function is. So you can't just put like f of x in there and it'll be a function. You have to see what the function is. So there's a couple of different common ones that we're going to look at, and I want to show you on Desmos what each of those looks like first, and then we'll talk about the general rules. Okay. So you may be familiar with the quadratic function. If I do f of x equals x squared, that is what we call a parabola, and that looks like this. That gets one of our most common ones just because it's easy to move left, right, up, or down. An exponential, in this case here with the base of 2, let me hide this here. You might say f of x equals 2 to the x power. And so that's going to be more or less what looks to be like a just constantly increasing function, getting steeper as x goes to the right. Absolute value, you can get the absolute value function by going down here or going on your keyboard and finding that vertical line. Absolute value is here. So if I do f of x equals absolute value of x, that's going to be a V-shaped, and that's going to look like this. And then finally, a rational function, which we'll learn in Unit 4, is going to look like this. F of x equals 1 divided by x. And those kind of have a weird symmetry thing going on where like you have this curved part here and there, and they don't seem to connect each other. But that's what a rational function is called. That's what it looks like. So those are some generic ones that we look at. But let's talk about the rules. And for the rules, I'm just going to stick with the quadratic to make it easier. Okay. So if I want to screw around with this first number here, if I start changing like a number out front. So if I do, let's say a times f of x. Let's see, yeah, a f of x. And I start playing with the number, and if I make a be bigger, you can see that's going to really narrow it up. And then if I make it be between 0 and 1, you see how it widens it. And then finally, if I make it negative, it flips over and does the same thing. So that a value really kind of changes the width and how it's opening on the x-axis. So let's talk about a couple things. If a is negative, it's going to reflect over the x-axis. If the number in a, ignoring the sign, if it's between 0 and 1, so if the absolute value of a, absolute value is just the whole positive number, is between 0 and 1, what's going to happen is that's going to compress. So let me put a 0 and a 1 there, and I'll show you how that works. So you can see here, if I bring that up to 1, it's the same function. But if I make that get closer and closer to 0, that's going to get much more wider than what it was here. Again, it's going to compress if it's between 0 and 1 from its original function. So we would call that a vertical compression. Compression. Okay, that's the key word there. Compresses, gets flatter. Okay. If a ends up being greater than 1, I'll write that up here. If the absolute value of a, whether it's negative or positive, is greater than 1, then it's going to stretch. So it's a vertical stretch. It stretches vertically. So keyword on there is stretch. See what happens when that value is greater than 1. I'll put a 1 there and let's say 100. And the higher I get above 1, that's going to get narrower and narrower and narrower. We call that a stretch. So narrow is stretch. I'll write that here. And compression is wider. Okay, so stretch, narrower, compression, wider. And then that negative, all the negative is doing is saying, you know what, I'm going to flip it over the x-axis. So when it's in the negatives, you'll see it do the same thing, but on the other side. All right, next, if I want that to go right or left, then I'm messing with what's inside of here. So if I look in here, that's going to be right or left, whatever that number is for h. So let's say it's let's do it x minus h. Now, if h ends up being, if I'm subtracting that number, it's going to take it to the right. If I'm subtracting a negative, it's going to take it to the left. So it's actually the opposite. That negative is flipping the sign. So it's opposite. If h is, if that's negative, it's actually going to go right, and positive is going to go left. So you can see if I just put like x minus 5, that actually took it 5 to the right, not 5 to the left. Now, if I did x plus 5, that's actually going to take it 5 to the left, even though it's a plus inside. So it's a little bit tricky because it's the opposite of what you would expect in there. And finally, I can do, if I go on the outside and I say plus 2, that's going to take it up 2. And if I do minus 4, that's going to take it down 4. So up and down is basically what's happening on the outside. So out here, this is going to be up or down k units. So those are your basic movements here. Again, a being negative is going to be reflecting over the x-axis. If it's between 0 and 1, ignoring the sign, it's going to be a vertical compression. If it's greater than 1, it's going to be stretched. It's going to be narrower. Inside of the grouping with x, it's going to go right if it's a negative, and it's going to go left if it's a positive. And finally, outside is just going to go up or down k units depending on the sign. So let's go ahead and work on the last example here. And we'll do this on paper, or then we can check it with the graph. So we have our parent function here, g of x is equal to x squared. And what we want to first come up with is a new function based off of the description here. So it says write the new function that resulted in a vertical compression by a factor of 1/2. Let's start with this, vertical compression by a factor of 1/2. The vertical compression is what happens on the outside, okay? So that negative, or sorry, that positive number in this case is going to be just 1/2. So what we'll do is we'll write g of x, and that's going to transform. Instead of saying x squared, it's going to be 1/2 and I'm going to leave that x open, okay, because we're going to do stuff right and left with it. But the 1/2 is going to go on the outside, okay? The next thing is going to be a translation of 5 units to the left. Left is inside of the parentheses. So that's the left rule. Remember, it's going to go left if it's a positive number inside the parentheses. So I actually want to take that 5 units inside and write plus 5. 5 units to the left. Close that up. And it says a reflection over the line, or over the x-axis. Reflection over the x-axis. Reflection means that the whole thing is on the outside going to be in negative. So my answer will be in negative, but don't forget that this had a square to it. So I want to make sure that that square gets put there to kind of keep it the same type of function, okay? So this negative is going to reflect it over the x-axis. The 1/2 is going to compress it. And the plus 5 is going to move it to the left 5 units. Now, what you're going to want to do is graph that. So put that in Desmos. What we'll first write is our original function. So I'm going to put x squared. You can just hit x. Clear that up. And hit the x squared button. And you can see it's a quadratic. That's the parent function. Now, if I go over here, I'm gonna type -1 divided by 2. That's the 1/2. Go to the right here, and I'm gonna do parentheses x plus 5, close parentheses, and then I'm gonna hit the square x squared button there, and you can see that it did move it left. It flipped over, and notice that it's wider. So that's the compression part. Okay, it's wider. It's reflected and moved to the left 5 units there. And the last part of example 4. So let's consider the parent function f of x and its transformed graph dash below. So the original function here, I'll darken. It says describe the transformations that occurred and write the equation of the transformed graph in function notation. So we're going to do it in function notation. So let's start first. What I like to do first is just kind of go, did it flip or get stretched or compressed? And it looks like it has the same width to it, but notice that it's opening down, okay? So because it flipped, it's going to be a reflection. And I want to do that part first because that's going to be the negative on the outside. So you would write the negative. So f of x is going to go to negative. And go ahead and write the f. But after you write the x, leave the open parentheses. In function notation, that's going to combine the right or left inside of the parentheses. So next, let's talk about what happened right or left. This point is now here, okay? That went 1, 2, 3 units to the right. So that's actually going to be not +3, it's going to be -3, because you remember that's going to be the opposite sign inside of it. So 3 units to the right is going to be like that. And then finally, it ended with going up 1, 2, 3, 4 units. So notice the y value here is 4, so it's going to be up 4. Now that's going to be +4 on the outside. So just in function notation, without getting into what the actual function is, that's what it looks like. It transformed to -f parentheses x minus 3 plus 4. Now, what kind of function is that? Well, if you look at the shape of it, and the ones that we jotted down up here, which one makes the most sense? Well, it turns out it's an absolute value function. So that's going to be an absolute value. And we're going to show on the graph a couple things. So for the most part, our notes are done, but if you want to stick around to see how I'm graphing it, continue doing so. All right, to graph an absolute value function, I'm going to type it as f of x, so f parentheses x equals. You don't have to type the f of x in, but I'm going to show you how the function notation helps us work with it. If you do f of x equals, and you're going to do the shift and the button above enter. Again, it's going to be this button right here. So if you hold down shift and this button, that'll pull the absolute value bars, or you can go into here. If that's closed, click over the calculator and click on this button here, and that'll pull the same thing up. You're just going to throw x in, and then you're going to call it good. That's your parent function. That's your absolute value function. And as you can see, that models this right here. Now, if I want it to test, does this give me the same thing? Once you've defined f of x, you can say -f parentheses x minus 3. And you can see the negative flipped it. So if I did one thing at a time, -f of x flipped it. And then the -3 is going to take it to the right, close the parentheses. And then if you hit +4, that's going to bring it up. So if I zoom in on that, that's going to be that same point that's right there, okay? Now, if you don't do this in function notation, it'll look like this. If I just did the absolute value of x, it would be negative. The absolute value of x, it'll still be -3. Close it up, and then you do the +4 on the outside. So whatever's in the groupings is the same thing as what's in here. So that's if you did not define f of x in Desmos yourself, but you get the same result if you type it in this way as well. Anyway, that's a little bit more than you needed to know on that for now, but I hope that you have a good understanding of how to evaluate functions, move them in the coordinate plane, and just kind of play around and understand what a function is. Thanks for watching these videos, and you all do very well in your assignment, and let your teacher know if you have any questions. Thanks again.